We are going to calculate gram formula mass for simple compounds. I'm going to start with a very simple one. I'm sure that this is review for most of you, but that's what these videos are going to be for, to review some concepts and to go over some things in class that we might be needing some practice with. So let's take our first formula, and we're going to take a nice simple one like water, H2O, and we are going to calculate the gram formula mass. Now keep in mind that gram formula mass is the total mass of all of the elements that make up that formula. So that's where we get gram, because we're going to calculate it in grams per mole. We're going to take the formula and we're going to take the mass. Okay, where do we get the mass from? We're going to get the mass from our periodic table. So that is right here. Let's see if I can show you. Take number 8652. Okay, there it is. So there's our periodic table, and the masses are going to be up here in the upper left hand corner. So those are the numbers that we're talking about when I say take the mass. That's our periodic table, that's our reference tables. Okay, so let's take water. The first thing we're going to do is we're going to write a list of all the elements that make up water. So we have hydrogen and we have oxygen. Okay, and then we're going to make a total of how many hydrogens are in this formula for water. We have 2 as a subscript here, and that 2 refers to how many hydrogens are written right in front of it. So we have 2 hydrogens, and we have a subscript here of 1 that's invisible. You can't see it, and the reason you can't see it is because it's typical that we wouldn't write the number 1 for a subscript. We just understand that it's there. So we have 1 oxygen. Okay. After we do that, we have to find out how much in grams per mole each one of these elements weigh. So we're going to go over to our periodic table again, and we'll look it up. And this number right here is 1.00794. Now the problem with that is it's a huge number, it's all complicated. So to keep things nice and simple, always round your numbers to the nearest tenth. So we're going to make it 1.0 grams per mole. And then for oxygen, we're going to have 16.0. And the reason we have 16.0, let's take a look here. Oxygen, right there. Let's see if I can zoom this. No, I guess not. Ooh, I just did. Look at that. Go me. Okay. So if you look at oxygen, and I'm assuming you have your periodic tables in front of you, but it's 15.9994. Well, again, that's a big sloppy number. So we're going to round that to 16.0 grams per mole. And now we have all the information that we need. We know that we have 2 hydrogens at 1 gram per mole apiece, and we have 1 oxygen at 16 grams per mole. So we're going to multiply those through so that we get the total mass of all the hydrogens. 2 times 1 is 2.0 grams per mole. And we have oxygen. We have 1 oxygen at 16 grams per mole. That's 16.0 grams per mole. It's nice, easy math, right? We don't even need a calculator. And then we're going to take those 2 numbers, nice and straight line. Make sure you do it nice and straight, just like I did. And then you're going to add those 2 numbers together, and we're going to get 18.0 grams per mole. Now, all of you guys know how much I love my little clouds, so I would put a nice cloud around this to make sure that everybody knew that was my gram formula mass. Now how do I get back to black is a whole nother issue. Okay, I think I did it. So this is my gram formula mass for water. Nice, easy, straightforward. All you do, just to recap, is you count the number of hydrogens in your formula, count the number of oxygens in your formula. If it wasn't hydrogens and oxygens, there'll be other elements. Count how many you have. Line them up with the masses that you obtained from your periodic table. Remember our periodic table, the masses are up here in the upper left-hand corner. Multiply them through, add them up, and down here you get your gram formula mass. Now let's try one that's just a little bit more complicated. Okay, let's try, I don't want to give too much away here. Let's try CaOH2. Okay, now before we go ahead and try to find the gram formula mass of this, I want to take this and name it, because we haven't done that in a while and we need a little bit of practice. So we're going to take this Ca and we're going to look up what the name of the Ca is, and you find that on your periodic tables. So if you don't know where to find it, you're going to find it on table S. Let me show you where it is. Scroll down, keep going. Okay, right here. It's on its side, I know, but if you find Ca, am I on the wrong page? I think I'm on the wrong page. Number 20, where are you? Oh, here it is. Okay, Ca, right there, calcium. Okay, find calcium, so we write down calcium. Ooh, I'm running too fast with my pen. And then we have to find what this OH is. And OH is in parentheses, so we know that it's a polyatomic ion. It's one of the 7 polyatomic ions that I told you should commit to memory because they're going to show up all the time. And sure enough, there it is. So let's scroll up to our polyatomic ion chart and let's find the OH, which is right here. And that OH is hydroxide, so it's calcium hydroxide. Okay? Now, we're not completely done with this. The last step that you should do when you are writing a formula from the formula to the name is to see if we need a Roman numeral in here. And if you need a Roman numeral, you would look at your periodic table, if I can find it, okay, calcium number 20, we just looked that up. Where is it? Take a ride on the wild side. Okay, calcium, you see how there's only one number here? If there's only one number there, you do not need a Roman numeral. So calcium does not need a Roman numeral. Now, if we had used chromium, for instance, or manganese, or, well, not molybdenum, if we had used one of these others that had more than one oxidation number, then you would need to put a Roman numeral in. Okay, so let's back up here. Calcium only has one. See, only one. And because it only has one, you don't need a Roman numeral. So this is our entire name for CaOH2. Alright, let's quickly get the gram formula mass done. Let's take calcium, oxygen, and hydrogen. Make a list of all your elements. Find out how many calciums you have in this formula. So calcium, there's only one. There's a subscript of 1 here. Again, you can't see it because it's not typically written if the subscript is 1. So you're going to put a 1 there. Now, oxygen and hydroxide, oxygen and hydrogen are inside these parentheses. And there's a 2 outside those parentheses, which will distribute to everything that's in the parentheses. So this oxygen, there's actually 2 of them. And this hydrogen, there's 2 of them, because there's 2 OHs. So we're going to put a 2 here, and we're going to put a 2 here. Now we can go and look up our masses on our periodic table. I got mine right here. And we're going to look up calcium, and you're going to see that it's 40.08. So we're going to round that to the nearest tenth, and we're going to make it 40.1 grams per mole. And we're going to have oxygen, which is, again, 16.0 grams per mole. I lost my... Ooh, come on, pen. Work for me. Okay, and we have hydrogen, which is 1 gram per mole. Really, pen? Okay, gram per mole. I'll work on this pen thing. So 1 times 40.1 will give us 40.1 grams per mole. There you go. And then 16 times 2 is 32.0 grams per mole. And then 2 times 1 is going to give us 2 grams per mole. Alright, now all we have to do is add these suckers up. Ooh, where'd it go? Uh-oh. Okay, headquarters, we have a problem. Oh, there it is. Okay, It's like learning to use a smartboard all over again. So 1 plus 0 is 1. 2 plus 2 is 4. Let's put our decimal in there so we don't lose it. 4 plus 3 is 7. 74.1 grams per mole. Okay? This number now is the gram formula mass for CaOH2. I'm going to try a different pen. Let me just see if this works a little bit better. There you go. Let's try it. Let's see if it works. Okay, so the calcium hydroxide has a gram formula mass of 74.1 grams per mole. Okay, we'll do percent composition in a few minutes.